Hey, my name is Alex, and this is lesson 27 for 7th grade math. For the first part, we need to evaluate the expressions. So for number 1, we have a square root of 24. And this isn't a perfect square. So what we can do is we could find the factors. So if we think about it, 8 and 3 multiplied to 24. And if we think about what multiplies up to 8 or the factors, you could use 4 and 2. And if you think about the factors of 4, you could use 2 and 2. Now from here, you could look at these prime numbers and you could take out pairs basically. So we have a pair of a 2 right here. So you could put a 2 on the outside. But if we take out these two 2's, then we still have a 2 and a 3 inside. So we could write a 2 and a 3 multiplying each other. So 2 times the square root of 2 times 3, which is 6. So the answer for number 1 is 2 times the square root of 6. Okay. For number 2, we have the same thing, square root of 88. 88 is not a perfect square, so we could take out pairs. 88 is also 8 times 11. 11 is a prime number. There's no factors except for 11 and 1. And for 8, we get 2 and 4. 4 is also 2 and 2. So if we look, we have a pair of 2. So you could take out a 2. But we also have a 2 and 11. So 2 times 11, or just 2 times 22. Number 3 right here, we have a 121. 121 is a special case because 121 is a perfect square, and you just really need to know it to be honest. Like there's no other way. 11 times 11 is 121, and 121 is a special case in that there's no other factors besides 11 times 11 and 121 and 1. So you automatically know it's just going to be 11. Okay. This next part, we're going to solve these quadratic equations, but we're going to use the square roots to do it. So for number 1, we have negative 21 equals 15 minus 2 times z squared. So if we want to solve for z, then we have to isolate it first. And we can do that by subtracting 15 on both sides. So if you do that, you get negative 36 equals negative 2z squared. And you could isolate the z squared even further by getting rid of this 2 by dividing both sides. You get 18 equals z squared. And from here, we have z squared equals 18. So the inverse of a square is a square root. So z equals plus or minus square root of 18. And 18 is not a perfect square, but we have 6 and 3. And 6 is also 2 and 3. So if we see here, we have a pair of 3 that we could take out. So z is also equal to plus or minus 3 times square root of 2, since we have a remainder of a 2 in here. Okay. Number 2, same thing. We're solving for c here. So we could isolate the c squared by dividing both sides by 7. So it becomes c squared equals 107. And the inverse of a square is a square root. So it becomes c equals square root of 100 over 7. And don't forget the plus or minus. And c equals plus or minus. And 100 is also 10 times 10. It's a perfect square. So on the top, we could just write it as 10 over square root of 7. But here, we have a square root of 7 on the bottom. And most teachers and most of the time, you shouldn't leave it like this. And this is called we have like an irrational number in the denominator. So to do this, or to make it better, you can multiply it by what's on the bottom, or the square root. So we can multiply this by square root 7, but on both top and bottom. So it becomes 10 times square root of 7 over 7. Okay, this next part is solving the equation. We have x minus 7 squared, equals 6. So to solve for the x, we need to isolate it, and we can do that by square rooting both sides, so it becomes x minus 7. Oops, this is a 7. Equals plus or minus square root of 6. X equals 7 plus or minus square root of 6. And here, unlike this square root of 18 or the square root of unlike the square root of 18, square root of 6 is also 3 and 2. There are no pairs that you could pull out, so that's why we just leave it as square root of 6. For number 2 here, you can isolate the x minus 3 squared by dividing both sides by 7, so 35 minus 7 is also 5. The inverse of a square is a square root, so it becomes x minus 3 equals plus or minus square root of 5. X equals 3 plus or minus square root of 5. And again, 5 is just a prime number, 5 and 1. There's nothing you can pull out, so you just leave it like this. Okay, 9, we got 4 over 3 times x minus 6 squared equals 20. You can isolate the x minus 6 squared by dividing both sides by 4 minus 3. Or you're also basically multiplying 20 times the reciprocal of 4 over 3 or 3 over 4. So it becomes x minus 6 squared equals 20 times 3 over 4 is one way you could think about it. And so this becomes 60 over 4. So if we do 60 over 4, then it becomes 15. And you could square root both sides, so it becomes x minus 6 equals plus or minus square root of 15. And this also equals 6 plus or minus square root of 15. Number 10, we should clean this up a little bit by getting the x squares on one side. So could add 2 squared to both sides, so it becomes 5 x squared equals, and then you could move the constants to the other side by adding 35 to both sides, so it becomes equals 80. You isolate the x squared by dividing both sides by 5. 80 divided by 5 is going to be 16. And if you square root both sides, you get x equals plus or minus square root of 16. But 16 is also 4 and 4. So it just becomes x equals plus or minus 4 for our answer.